welcome to session number 27 of the Mastering Mandelbulb 3D Formulas. We're going to take it easy here. We're going to take it nice and slow because we're moving into probably the most complex area of the Mandelbulb formula topics, and I would dare say that the DEcombinate hybrid mode is probably the least used, the least understood, the hardest to work with, and the most difficult to understand what just happened. So we're going to take it easy on this one. I can tell you this, that when you master the DEcombinate mode, you have really unlocked some extreme power of the Mandelbulb 3D application. And the reason for that is because the DEcombinate mode is what they often refer to in visual effects circles. They talk about it being a volumetric Boolean logic. All right. I'm not really sure where they came up with the DEcombinate name or title. I believe that the DE refers to the distance estimate method of rendering out these Mandelbulb objects. It's kind of an old style ray tracing. The DE, the distance estimate. I talked about this in the Mandelbulb tutorial series number 1, where we were going through the animation, creating an animation, and at some point we got to the point where we were talking about this distance estimation technology, where it's a method of determining where an object in space would be, and we can kind of equate it to the newer style ray tracing. Actually, ray tracing is not newer style. That's probably that could be 5 years old by now. They have much better ways of rendering out a three-dimensional type of a graphic environment. But the DE, the distance estimation, is a method that was used to determine these graphical three-dimensional shapes back when the Mandelbulb 3D application was made. So the DEcombinate, most likely, and from whatever reading I was able to do, is where the internal algorithms of the Mandelbulb 3D application are actually combining the distance estimate calculations that occur in order to produce the graphic on the screen. All right, now let me clean this up a little bit here. Let's reset and recalculate. All right, now the DEcombinate, like I mentioned a couple of minutes ago, it is volumetric Boolean type logic. And where the Mandelbulb object is being determined by combining multiple formulas, but the internal process is really looking for, is really geared towards the rendering. All right. Now, if you remember escape time formulas, okay, where we're talking about the alternate hybrid mode, we were talking about it, layering, okay? Produce the object, put it on the screen, produce the next formula object, put it on the screen, next one, put it on the screen. Then we talked about the interpolate hybrid mode, and that's where you have two formulas that are combined, where the average, all right, of the two are combined for the Mandelbulb object on the screen. Now, the DEcombinate sort of kind of works in a similar manner. The difference is that when I say volumetric Boolean, basically that means that you can actually have a shape that's created by a formula, and then you can have another shape or formula that actually extracts some of the previous object that was created by the previous formula. So this is referred to as Boolean, where you can AND multiple objects together, mathematically AND, not just throw them on the screen, but mathematically AND them together, mix them in together, or a subtraction or a Boolean not, where you're taking some of this object away from, okay? Or you could have there's other Boolean methodology. It's not important right now because I don't want to get ahead of you, and because I want you to understand the Mandelbulb3D application without really having to know the math. Okay, so the DEcombinate is it's a methodology by which multiple Mandelbulb objects can be run and have an impact on one another in terms of their volume. All right. The interpolate was an averaging where they were averaging the result of two different formulas. In the DEcombinate, you can actually have up to 6 formulas. As a matter of fact, let's take a look at the DEcombinate slot here. All right, I can have 6 formulas in DEcombinate. So I'm not restricted to only 2 like I was in the interpolate mode. All right. Come on, get off the screen there. Okay. So let's just practice with this. Let's see what happens, okay? Let me take integer power. I'm in DEcombinate mode now. All right, and I'm going to say, I don't know, I'm just going to pick cube quat and calculate that. Okay. Now, if I was to run both of these formulas separately, I would see 2 different objects there. Now let's see if I can do it. All right, because this is important. Do you see 2 different objects in that screen? You see 2 different Mandelbulb objects? All right, one Mandelbulb object is our integer power, like our flower thing that we've been looking at all this time. The other one is some sort of a candy cane type. Let's see if I can isolate the 2 separately. What if I was to, oh, there's that drop down. What an annoying thing that is. Let's take formula number 1, which is integer power, and let's have that an iteration count of 1. Let's take our cubic quat, knock that down to an iteration of 0, calculate it. Calculate it. It doesn't like it. Error. Formula option is not valid, so I can't do that. In the DEcombinate, I have to have 2 formulas executing. I can't just have one formula because it's a combinate. It's combining. It's volumetrically combining 2 different objects. So I have to have more than one object in order for DEcombinate to work. Write that down. You have to have more than one formula in DEcombinate to work. Okay, so what I see on the screen there is I've got 2 different Mandelbulb objects that have been volumetrically combined, where they're mixed in with one another. they're ANDed together. There's that Boolean, they're ANDed together. Let's take, let's just change the formula to, I don't know, A Tetris VS in formula slot number 2. Formula slot number 1 is still integer power. Let's DEcombinate these two together. Okay, all right. All right, do you see here, do you see our integer power? And you see here our A Tetris VS. All right, so I have my integer power bulb, I have my Tetris VS, and they're mixed together. They're ANDed together. Now this is with all of the standard properties, default properties. I haven't modified any properties, and this is what I get. So this is a good example of the DEcombinate, which you can think of as a combining. Technically, it's volumetric Boolean. We can think of it as combining two different, or I shouldn't say multiple, fractal objects together. All right. Go refresh the coffee or the tea, whatever you need. All right, because this DEcombinate, like I was saying, can get pretty deep. But if you master this, if you master DEcombinate, you got it. I'll see you in the next session.